You are now listening to Out of the Blank.
Welcome to another episode of Out of the Blank podcast. I'm here with Heystek Grobler.
Hey, hi, Rob.
I got it, didn't I?
Yes.
So tell me a little bit about yourself and what do you do professionally?
Okay, so I'm still a master's student and also a researcher. I work in the field of radio astronomy.
Radio astronomy.
Hmm.
Now, what do we mean by radio astronomy?
Radio astronomy, the best way I can explain it is normal telescopes look into the night sky to various objects. Radio telescopes does exactly the same thing. But radio telescopes look at electromagnetic spectrum that we pick up from celestial objects. So if you imagine having a piano in front of you with all your different white keys and black keys, visible light forms part of the electromagnetic spectrum. So visible light will be one of the black keys on your piano, and the electromagnetic spectrum will be all the other keys, including the visible light key as well. So with a radio telescope, you're able to see more of what's happening out in space than through a normal optical telescope.
So what's the exact importance of trying to study this?
So one of the so using telescopes across the globe, optical telescopes, radio telescopes, we try to figure out what's happening out in space, and in return, how everything works. So there's two branches of astronomy. The one is normal astronomy, where we study what's happening in space. And the other part is called geodesy, where we use astronomy techniques to study the Earth. And these two complement each other extremely well.
And astronomy, so that's the study of stars. I've talked to a few astronomers on that. But when it comes to the aspect of studying radio frequencies, like I think a
Mhm.
lot of people, when they hear radio astronomy, they don't really take into consideration the fact that everything from our cell phone, from technology, anything that produces a signal, people are known to tend to give off a bit of a signal. But when it comes to our cell phones, for instance, there's a invisible wave that is going from my cell phone straight up into a satellite right now that we cannot perceive.
Mhm.
We have to learn to be able to kind of study and I guess calculate the whole point of these radio frequencies as well. There's a lot we really don't understand because seeing is believing, and for a lot of people, they just can't really understand that concept.
That's actually a very good point, and also interesting topic to discuss. But a good example is if we take a look at the center of our own galaxy, for example. You can get really nice, interesting images from the center of our galaxy and different objects. You can get a nice visual representation of what's happening. But if you look at the electromagnetic spectrum, some objects emit X-rays, some emit gamma rays, some even emit radio frequencies. And by examining those frequencies emanating from space, you can learn a few more things about that objects we're observing.
Now, did radio astronomy, did that first start because of the whole fact is I know there was something a long time ago where it sounded like we picked up a signal from outer space, and that kind of enhanced our wonder if there was anything else out there. Everyone's has this idea of little green men or something, but I mean, one of the first things we did, I'm pretty sure we shot off either it was a song or we did something where we sent it off into outer space in case any aliens come in contact with it. The fact is that would be their first interpretation of who we are as a species.
So how radio astronomy as a field started back in the 1930s with a guy called Jansky. And during that time, he was working for Bell Laboratories, and he was working on a radar system. And he kept picking up a weird frequency sitting at around about 22 gigahertz. And he decided, well, he's going to try and figure out where the signal is coming from. So he built himself a large antenna that's basically a radio telescope. And he started moving it around, pointing it to different places to see who is creating the signal at 22 gigahertz. And then later on, he determined, well, it's not coming from Earth. That signal is actually coming from space. And he wrote a paper. No one believed him. And then a couple of years later, other guy, Reba, built a telescope, and he said, well, he's going to investigate this further. And he also determined that there's actually a signal at 22 gigahertz coming from space. And after more investigation, it's determined when the Big Bang happened, that left behind a frequency. We call it a cosmic radio wave background. And that's the remnants of the Big Bang that's still be able to see. So usually when you turn on your analog radios or analog TVs and you hear that white noise at the back,
Yeah,
that's coming
down here we call that snow on the TV when you turn it on.
Oh, snow on the TV. Okay. And that's basically the remnants of the cosmic radio background emanating everywhere from the galaxy.
Now, why was it so hard to believe that there was a sound coming from outer space? I know there was a thought or there was a belief that when the meteor hit Earth, I guess the one that broke up and created diverted all the continents, the ones that created Pangaea, that there was a really, like, once it hit so hard that there was literally a ringing that was going on for a couple thousand years or million years. And if to think, we still have things on this earth that we are not able to discover a sound frequency. There's a thing called a bloop. Have you ever heard of this?
Yes.
Yeah, the bloop. Nobody knows what that is. We have no clue. And then we don't have the resources or the technology yet to go down there and figure out what it is, because there's still so much left of the ocean. So it really boggles my mind to see, like, the amount of technology you can see now with just devices in general, the fact that I can communicate through a computer to you, sending off a frequency going, you're basically across the globe from me, and being able to communicate in that way. How could you ever think that at one point in our history, we thought this was unbelievable? Like the guy who started this was just crazy.
That usually is the case. People get these, in science, we get these things we can't explain and we start investigating it. And if we can't investigate it, we develop new technologies and better methods to see if we can study something. And usually the research going into it will create new technologies that everybody else can use. And also then we are able also to find out what's causing certain phenomena. Take, for example, the Apollo missions to the moon. A lot of the technology developed for communications are now being used in cell phones, your tablets, computers. So it takes a couple of years, but everything being developed actually ciphers down to everything that we use.
And using just the basis, like, why is it the fact that a star is giving off a certain emitter, or being able to send out a certain radio wave? How is that even possible if it's just an object that we know as light? I'm guessing there's way too much about it that we just don't understand yet.
So that's where the electromagnetic spectrum comes from. So if I can suggest all the listeners, if they have some spare time, just to Google the electromagnetic spectrum, you'll see the electromagnetic spectrum. You have frequency on the one axis and wavelength on the other axis. So usually the higher the frequency, the smaller the wavelength, and the lower the frequency, the higher the wavelength. So certain objects emit certain waves. For example, visible light is also waves. If you think about green light, I don't remember the figure off my head, but I think it's something like 513 nanometers, the wavelength of green light. And it also has a frequency. And so if you look at different objects in electromagnetic spectrum, we can determine its composition. Sometimes if the frequency it's emitting is in the audible range, then we can hear it. But certain elements, for example, emit certain frequencies or absorb certain frequencies. So if we look, for example, to determine the atmospheric composition of a planet in a different solar system, we wait one of the methods we use is we wait for that planet to move in front of its star, and then we can look through its atmosphere. And we know certain elements emit certain frequencies and certain elements absorb certain frequencies. And we look for that emission and absorption spectra. And then from there on, we can determine, the atmosphere might have oxygen, it might have nitrogen, might have helium, and we can start figuring out what's happening inside that planet's atmosphere.
And that's just because the whole factor is that there is basically two ways we can kind of distinct or kind of tell what radio waves are, and that's the two basic forms, which I'm guessing is probably thermal and non-thermal.
Yes.
Okay. And we can only pick up some of these things. That's why we can't see like X-ray stuff. Like when you're getting an X-ray, you don't see the waves that are emitting off it, even though it is producing radiation. I only I
Yes.
only think of that. See, the first example I think of is I had a crack in my microwave when I was a kid. So whenever you heat something up, you would run to the other room because you thought if you stood there. I mean, yeah, I don't know how many times I'm heating up a hot pocket, I'm heating up something, and my like when you're bent over like you're tired, you just put your hands on the counter and put your head in your hands.
Mhm.
My head was right next to that microwave with a crack in it, and I wonder how much radiation I actually received from that. Probably very, very minimal, but I always like to joke around about it. But the fact is, there are things that our eyes cannot perceive, which a lot of people don't understand. It's a weird thing. If you look up people that can see sound, they can literally see the wavelengths and the frequencies that are able to do this.
Mhm.
And a lot of times you can use a device, such as the technology that we have now, is being able to create devices that can help us kind of study these and be
Mhm.
able to see what impacts us around us. Because a lot of people only see you know, the physical stuff like, oh, if you get hit by a car, I just got hit by a car. But did you see the frequencies, the radio lengths, all these things that are constantly going in and out of us every single day that we don't even take into account?
And that's actually also a scary thought because we get bombarded every day with particles from outer space. We get bombarded with X-rays. We get bombarded with gamma rays. And most of these particles or waves just move through us. You need something, a dense material to actually capture and stop them like lead and concrete. That's also where heat comes from. So if you look at our sun, the heat we feel on our skin is infrared. That's emanating also from the electromagnetic spectrum. So you have your visible light. Next to your visible light, you have infrared. You can't see it, but it emanates heat. And if you go up to high frequencies, you start getting to X-rays. And
Mm.
the X-rays is what's caused, you can't see it, but that's what causes all the skin cancers and problems you can find. And that can also penetrate through denser materials. So that's why we can take an X-ray of our bodies, because the X-rays moves through our skin, through our organs, but our bones reflect back the X-rays. And we can actually see, create a map of your body using where the X-rays are reflecting from.
And that's the same thing that we're technically doing with satellites. We're kind of creating a map of the galaxy a little bit in a way just by studying radio frequencies and wavelengths that are kind of giving off by the stars and planets and things of this sort.
Yes, so for example, if we take a visual optical telescope, and we point it to a star, we can see, okay, the star has a yellowish orange color, it has solar flares, that's what's happening. But if you point a radio telescope towards a star, we start picking up X-rays coming from the star, or infrared or gamma rays. So we can actually see, infrared, you can see deeper into the star. Say, for example, if you take an X-ray of our body, we can see the skeleton inside. The same thing happens when you look at the radio waves coming from stars and planets. You can actually see a little bit deeper what's happening inside that star and planet.
I'm tr- See, the first thing that come to my mind when I think of radio astronomy, not just the study of stars, but I'm just picturing like what people initially thought when someone was able to send a frequency or a wavelength or
Mhm.
something, like when we received information or we got a reading of something out there in space, like there's a sound out in space. Like, what are you talking about, Bill? What do you mean there's a sound out in space? What are
Mhm.
you nuts, man? Maybe you just got like someone's got their cell phone on in the next room. They start thinking like, no, maybe there's aliens out there. Like maybe that's why we even choose to pursue what it was. Like, is there someone out there sending us a signal? Like, is anybody out there? That whole thing. And it really to see how far we've kind of gone from that kind of mindset to where we are at now, where we're starting to learn that there's a lot of information locked inside of these things that we are just considering energy or balls of light.
That's actually true. But one thing I can recommend for listeners in the US, if they're ever in the area, I've been there a couple of times. It's the Greenbank Telescope situated in West Virginia, Greenbank. It's currently the world's third largest radio telescope. That's a single telescope, fully steerable. It's about the size of a football field, and it's higher than the Statue of Liberty. So it's 110 meters in diameter and about 147 feet high. And that's extreme engineering and scientific marvel sitting in West Virginia, and is being used for great scientific research. And that telescope is not only used for astronomy. What was it when the latest rover landed on Mars? I think it's not Curiosity, the one after Curiosity. I can't remember the name of but they used a telescope to actually track the telemetry of the rover landing on Mars to make sure everything's happening according to plan, because we have radio frequencies and radio beacons emitting from the rover, and a radio telescope can pick it up, so you can actually see if everything's going according to plan, if we can land a rover on Mars.
Okay, so this is helping us with our space travel as well. See,
Yes.
when you say radio antenna, you say this type of thing. We think of the immediate one that goes into our head, like a telescope. We think, oh, I could stick my eye to that, or an antenna, like something they see with cell phone towers or something. But these are
Yes.
those giant satellites that you see in like the Incredible Hulk, these types of movies where you're like, what is that for? It's like, oh, that's our communications. It's like, yeah, but it's communicating something completely different. It's a whole type of being able to beam past everything into outer space as well. How difficult does this make your job? The fact is that there are so many things that are being created on Earth that could be impeding onto just being able to get a good reading of a wave frequency in outer space.
That's a big problem. So the observatory where I am at is the RTBS Radio Astronomy Observatory. It forms part of the South African National Radio Astronomy Observatory. And radio frequencies emanating from humans and us is a major problem, because your cell phone is emanating radio frequencies, Bluetooth, Wi-Fi, microwaves, even your petrol vehicle's spark plugs is causing interference. So usually where a radio telescope or radio antenna is that's been used for astronomy purposes, there's they call it a radio exclusion zone or radio quiet zone around the site, where no cell phones are allowed, no TVs are allowed, no Wi-Fi, no Bluetooth. Anything that can cause interference is then eliminated out. So if we pick up then something from space, we are sure it's coming from space, and we do quite regular sweeps of the area to see if something causes interference. For example, the Greenbank Telescope in West Virginia has a 60-mile radius exclusion zone. It's called the National Radio Exclusion Zone. And there's nothing, no overhead lines, no Wi-Fi, no cell phone, no Bluetooth. So if you want to communicate with someone there, you actually have to use an old-school landline phone, or through the internet. You can use your laptop, you plug in an Ethernet cable, and you're good to go for communications. But further, nothing else is allowed to try and minimize interference from our own planet as much as possible.
Nothing that can interfere with a certain frequency or wavelength that we're trying to read.
Yes.
Now, see, this is where it gets crazy. How is our antennas able to focus past all that, even with some isolation? It seems like just trying to get out of Earth's atmosphere in general, or even into space. I mean, we're launching probes, we're doing so many different things that are sending off different frequencies. How are we able to pinpoint it?
So usually when we have our satellites in orbit, we know the frequencies they are emitting. So that's some frequencies we can cancel out. And for example, we know Bluetooth, for example, and Wi-Fi is operating at around about 2.4 gigahertz in frequency. So if we pick up something from space that's somewhere in that range, we double check, is it something emanating near the telescope, or is it actually coming from space? And if it's coming from space, then we ask a different telescope from a different part of the world to just double check the readings to see if they can also see, they can pick up the same thing, just to double check if we are detecting something new or if someone is emulating something near the telescope.
Does this cause the kind of like for people like you that are
Mhm.
researching all this and being involved in it constantly, does it cause you to look at radio frequencies on Earth a little bit differently? Well, like we're talking about the things that our cars can give off, the things that our cell phones can give off, all these different types of different radio frequencies. I have to feel like that crosses your mind a lot of the time.
It does, really. And one thing that's causing big problems at our facilities is these LED lights that we have in our homes and those downlighters from our ceilings. Just a normal LED light operating at around about between 5 watts to 15 watts, even to 50 watts if you want a really powerful light. But those have a little power supply that drives the LED called the switch mode power supply. And all that switch mode power supply does is it switches on the LED very fast. Your eye can't detect the flickering of the LED, but that's what a power supply does. And that turning on and off, on and off, on and off from that power supply causes interference on the telescope.
Because that's sending an invisible frequency from one source to another, which is telling it to turn off and on.
Yes.
See, now this brings up a weird idea. So the fact is, you know how LED lights are bright as shit. I don't
Mm-hmm.
want to sugarcoat it. They're very, very bright. I don't
Yeah.
like them. I like the the regular yellow light that we were kind of started off with. So the LED lights are creating more of an impact, and the fact that people are getting them more and more and more makes it a little bit more, like you're saying, it makes it kind of a concern, just because they're operating at a higher frequency, which is causing a little bit more of an interference that we have to be able to pinpoint what wavelength they're giving off. Like you said, our cell phones are giving off a certain wavelength that we can kind of
Yes.
we could tell, like, oh, it's probably
Mhm.
3.2 or whatever this is.
Yeah.
LEDs are creating something new where we're like, is that an LED light or is that something? I don't know, because we don't have the exact number pinned down.
Yes, that's exactly what's happening currently. And one thing with LEDs is it causes a range of frequencies. So we pick up a lot of, we call it noise, and we don't know if that noise is coming actually from LED lights or from outer space. So the best is just to, so we don't have any LED lights at the observatory, just to cancel out that effect, to make sure we can pick up everything from space. But a new problem that's emerging now is, I know Elon Musk. I'm a big fan of Elon Musk, a big fan of SpaceX and what he's achieving. But with his Starlink satellites, we wants to put a constellation of satellites in orbit and provide internet services around the globe for everyone. Very, very good idea, very brilliant idea. But on the downside, it blinds radio telescopes at certain frequencies.
Yeah, he's sending off like Teslas into outer space. Like, you want to talk about picking up a certain reading. Like, I think I just found a flying saucer. Nope, that's Elon Musk Tesla floating right by.
Yeah. And just to give an example of how sensitive these telescopes are, the Greenbank Telescope, if you theoretically put a cell phone on Mars, you will completely blind the telescope because that will be the strongest radio source in the sky.
Oh shit. So literally creating a signal on Mars would help us be able to communicate with maybe space travel and do things of this sort, but it would totally
Yeah.
blind us from being able to get any research or data from any stars nearby. The fact is that we're looking at space, it's blank, it's pure, because all that information we're getting is raw. It has not been messed with yet. If you try to pull out any information on frequencies down here on Earth, it's that's art. That time for that is done, because the fact is we have so many devices and so many things now that would impede on perfect readings.
Yes.
We'll be able to communicate like, oh yeah, yeah, it's between this signal and this signal. That's about a range of a cell phone, but it makes it more difficult to find any more information out on what we have here, because of the fact is sometimes there could be a thing that could change the frequency, such as like with LED lights. For saying, you're saying they come in different kind of strengths, I would say.
Yes.
when a when an LED light is buzzing, like a bzzz, like you hear that, you
Hmm.
said we heard it as sound. That just
Yes.
means it might be at a lower frequency that our ears can pick up, kind of like a dog whistle.
Yes.
Oh shit, I'm learning.
Yeah.
I'm
Exactly
learning.
like that. And these are quite interesting problems we are dealing with. So we have a few experts doing research of how to block out or cancel out these certain frequencies created by us, so we can distinguish that from frequencies we can pick up from space. And that also gives a few interesting engineering challenges, because how do you actually isolate a frequency and then block it out from your telescope? And that's actually also a very nice, fun research area, but that can also become quite mind-boggling if you try to figure out of how can you block out a certain frequency or cancel out of how do you stop a certain frequency of being created on Earth. But on the positive side is that's how SETI works. SETI, the Search for Extraterrestrial Intelligence, has a subgroup called Breakthrough Listen. So since the early 1900s, let's say in 1800s, early 1900s, we have been creating radio waves, and throughout the years, we have different electronic devices, and these radiate different frequencies. For example, your cell phone operating 2.4 gigahertz. I see now Wi-Fi at 5.5 gigahertz. That's emanating from Earth. So radio frequencies or the electromagnetic spectrum travels at the speed of light. So if this is Earth, there's a bubble of radio waves emanating from around Earth going out in space. So the theory is if there's another civilization somewhere out there, and they have also created communication devices such as radios, television, cell phones, they will also have a radio bubble emanating from their world, emanating from outer space. So what Breakthrough Listen does is they are looking for these radio bubbles to see if we can't pick up a radio bubble from somewhere. And that's one way.
Much like our radio, when we're tuning in the channel or seeking for a channel on a radio station, you hear that shh, but it's like more
Yes.
like it's like blank kind of noise, and then you just hear a bunch giving off. So like if somebody, let's say, if me and you are looking for planets, okay, we're gonna what kind of flying saucer do you want? Do you want a circle one? Do you want a square one? Do you want one like the Enterprise?
Yeah, let's go with the Enterprise.
All right. We're floating around in the Enterprise, okay? So we turn on the radio signal to try and be able to read something. So let's say we're tuning in on the channels. It's just nothing, complete sound and silence. And then suddenly we get our like a bunch of different things going off, like $3.95 for 2 knives, $4.95 for 5 knives. You're like, whoa, 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 what was that? And we tune back. That's what you're saying with a planet giving off that bubble. It's that frequency that we're able to pick up. It's not as simple as that, though. Like our antennas, like, see, the thing is, when we look at astronomy, looking through a telescope, you are able to see past everything else that is impeding onto your view of whatever you're trying to look at. You got the pinpoint. You can be like, all right, I'm looking at that star, and you're staring straight up at it. And so if something comes by, your eyes can look past it. You can look right directly at it, as long as it's not right in front of it. But with a radio frequency, that it's not that simple, because the fact is you are using a machine to try and communicate and try and convey the wavelength to your ears.
Yes, so one way to think about the radio astronomy as well is you can look mathematically at what you're observing, because radio frequencies can be translated into math. And in the math, you can actually see what's going on, and you can get a nice, better representation of what's happening rather than listening to it or seeing or trying to look at it. You can actually look at the math. You can create plots where you have your power of the signal of the frequency on one axis. So you have power on your y-axis and frequency on your x-axis. Then you'll see spikes where you pick up different frequencies, and that's one other way you can look at it. So normal telescope that you look through, you can point it to an object and you are sure you are pointing it to an object. The radio telescope is built that it looks like a parabola, and that parabola acts as a normal telescope. You can point that parabola to a certain object in space, and due to the form of the parabola, it's like shining a flashlight towards something. So you can make sure you're actually pointing to the object you want to point, and you can see what you can detect from that object.
And the farther away that we're trying to detect, the more signals we're going to be able to pick up, just because of the fact it's like a funnel. Like when you extend a flashlight out, where it's the most thin is at the start where the energy is kind of giving off, but then it funnels outwards the farther it goes.
Yes, exactly the same thing happens with a radio telescope.
I'm learning right now, dude.
So,
I'm trying at least. When it comes to like you see, immediately when you start thinking of being able to detect these things, I immediately start thinking of a guy with a handle that's like the size of like what you would crank open a dungeon door, and he's
oh
just sitting there
yes.
like rotating the fucking thing, trying to get the telescope to
So,
turn. But it's really simple. It's kind of more like typing in a certain calculation onto a computer and then being able to turn them a certain way to be able to pinpoint and try and find these sources of wavelengths.
yes, exactly. So we have computer systems that drive these telescopes, and we know we have certain coordinates of where the stars and objects are. So then you point your telescope to whatever part of the sky you want to observe, and then we see what we can detect from that part of the sky or that object. So we have how it works at a normal observatory is if you want to observe a certain object or certain part of the sky, you write a proposal of this is what you want to observe or this is what you want to do, and a committee decides if the research you want to do, what you want to observe, is worthwhile, if there's something interesting about it. If it's worthwhile, then you get assigned X amount of time on a telescope, and you could be at a telescope while the observations are being done, or one of the operational staff at a telescope can do the observation for you and just send you the data that's being detected by the telescope. And you can analyze the data and see if you were correct, if there was something interesting happening in that part of the sky, or if nothing's happening there.
What's the type of information that we're hoping to be able to find? Is it just on the matter of fact that we might think we're not the only ones out here in this universe? It feels like when Ronald Reagan gave that speech saying, I don't believe there are aliens out there, but if there is, I want to be prepared for anything. And then he made a couple government programs to be able to study extraterrestrial life. It seems like with radio astronomy, this is kind of what we're focusing on. But what is the main source of information that we're trying to pull out? Just besides studying wavelengths, like what is the importance of any of this when we have so many problems here?
So best thing to describe is us as humans are very curious. So we are constantly searching for what happens. So we are a curious species. So if something makes a noise, we're going to see, example, walk around, try to determine what makes that noise. If something grows in a certain way, you're going to see, oh, this plant has beautiful flowers. Where does this plant comes from? Where can it grow? The same thing is we're curious. So we want to know what's happening in space. So with the wavelengths we're detecting from space, we can determine the distance from certain objects, how fast certain objects is moving, what direction they are moving in, what is their composition, what are they made of, and actually what makes them tick. A great example that was in the news in last year was the first ever image created captured from a black hole.
Yeah.
So if you think about a black hole, it's literally nothing. So not even visible light can escape a black hole. So how do you actually take a photo of something that doesn't emit light? So the best way to do it is to point a couple of radio telescopes to where the black hole is. And there's a certain point or a ring around a black hole called the event horizon. So everything before the event horizon is fine. Everything after the event horizon is pulled into the black hole. So the first image ever taken from a black hole is actually X-rays going around the event horizon. So we can't see the black hole itself, but we can see the event horizon around the black hole, the point of where the X-rays is sucked into the black hole and the point where everything is fine around the black hole.
So mostly like when we're being able to study and do a lot of research on the stars and things like black holes and being able to figure out like certain wavelengths, I guess you would say, this is just helping us in our own information of being able to understand and first of all be able to expand our space travel as well too. It seems like when we know more about space, we're being able to communicate and find better ways of maybe travel, such things as setting up a better system here as well.
That as well, because all the technology being developed to do astronomy, in a couple of years, that technology will be available for the general public to use. That's why everybody can Now, buy a decent computer that's decently priced, because a lot of computing hardware has been created for astronomy and scientific purposes, and now that is ciphered through, and everybody can basically get their hands on a decent computer now, and that's due to scientific research. And it's also nice to be curious of what's going on. So a while ago I spoke about geodesy. That's the inverse of astronomy. So we also use these technologies and techniques to study Earth. So geodesy, one of the best things that geodesy does is if we look at an object that's in a different galaxy, and all of a sudden that object moved, that's impossible. That actually means the object didn't move, but the telescope actually moved. So by monitoring objects in different galaxies, we can actually track the movement of our telescopes, but a telescope can't physically move, which means the continental plates is actually moving and drifting. So that's one way we can calculate continental drift. So we've calculated the African continent is moving around about 2 centimeters per year towards India.
Okay, so this might be a problem in the near future, just with the idea of collision in general.
Yes.
So I'm trying to think here, because the whole concept of we're pulling out information from space, like I'm trying to wonder, can it be as simple as if we have a meteorite or maybe an asteroid that's kind of floating through space? Can that give off a certain frequency or maybe block a certain frequency that we're kind of reading to be able to tell if we can kind of pinpoint when it might exactly hit us if there was one coming at us?
Yes, that's exactly what we're doing. So we monitor the night sky, and if we actually see something on a radio telescope that's emitting a frequency, absorbing a frequency, we know there's something there. And then we can actually figure out how the size of it, what's the speed it's traveling at, what direction it's traveling at, what's its orbit, its trajectory. And we can figure out if it's going to hit Earth, if it's going to miss Earth. So if it's going to hit Earth, then you start figuring out plans of what can we do to stop the collision. If it's big enough, will it do any damage? If it's small enough, then we just let it slide. So NASA has a nice asteroid tracking program where they use telescopes from around the globe, radio and optical, to track any objects in our solar system to see if some of them are dangerous or something was not dangerous.
Where do you see more concern in your mind or in your opinion with just radio astronomy in general? Just the idea of what else could be out there. I feel like it's great for, if we're trying to measure the ozone layer or something, or be able to kind of read off, like, because, the sun gives off an extreme amount of radiation, but there's a giant thing protecting us right now. It's also why it's like 70 degrees in fucking January, which is crazy. Global warming is real. But the whole concept is, what in your mind, though, is most important? Would you say that is there a concern out there in space that you might think or might end up happening? We're talking about Africa getting closer to, India. That's a problem. I mean, they separated at some point, and it's been a long, long, long time. It's hard to think that at one point those pieces aren't just going to drift right back into each other, but not the way it came together, more like going so far out of bounds that they're going to crash into each other.
So if continental drift, that's going to happen in a couple of million years, where different continents will slam into each other once again. So we can model and calculate the movement of these continents to see what's going to happen. But at some stage in the future, they're going to smash into each other and may create one super giant continent again, or break off in a little bit smaller pieces again. And with astronomy, there's so many different interesting things happening in space. I'm just curious to see what's happening out there, what can we learn from outer space. And through these, we can also learn what will happen in Earth's own future. And for example, our own sun, you need a certain mass for a star to go supernova, or it will just dim and die out. So our star is quite a smallish star. So in about 4 billion years, our sun will expand and expand and expand, and it will
Implode.
Not implode, but it will eat up all the first planets: Mercury, Venus, Mars, and Earth will then be inside the sun, and then it will start just dimming out and dying out.
Thank God it's not going to happen in my lifetime.
No, that's one of the things that's happening in space. And speaking about also these asteroids, I don't know if you know, but it's actually quite interesting. Our big brother looking after us in space is
It's
Jupiter.
Mars. Oh, wait, no. Jupiter, that's right, because Jupiter is technically what we would call our protector, only because its gravitational pull. There's actually it was. I'm pretty sure what you're talking about is a few years ago. There was around the time like near Halloween in October. There was an asteroid that nobody fucking knew about because it was coming at us like direct impact. But the fact was, I don't know if it wasn't Mars or was it?
Yes, Jupiter.
It was Jupiter that
Jupiter's,
that blocked it. That's what I'm talking about.
yes.
Yeah, yeah,
Yeah,
yeah.
Jupiter's gravitational pull is so large that it pulls different meteors and asteroids coming into the solar system, and it just pulls it towards it, and that misses Earth. So you can think about Jupiter as our big brother looking out for us, protecting us from different objects in
Literally, we
space
didn't.
as
We
well.
we had no clue. We were literally going around getting Halloween candy and shit. And there could have been an asteroid that could have totally just wiped out so much of the population on Earth. But the whole factor is like, I thought of that when I looked. I came across an article that gave me that information, and it made me look at the moon completely differently. Like if you look at the moon, even though that is technically whatever an asteroid, it is whatever but all the little holes, all the little craters that are on top of it are all things from space that have been bumped into it.
Yes. So because the moon has no atmosphere, if something smashes into the moon, it stays as it is. We can actually see the scars. We can see the craters of what actually hit the moon and what's going on. Something interesting about the moon actually was a piece of Earth that tore off while the planets were still forming in our solar system. And it just got locked into the gravitational pull of Earth and it remained there until now.
And that was from, I'm guessing, the original impact of that giant asteroid that broke up and made or turned Pangaea into what we have now.
And that's even before that, while Earth was still being formed.
Oh, man. See, there's so much about space where someone starts talking about it, I immediately start thinking, like, just when I was a kid staring up at a globe. I mean, where did you get your first interest in space in general? Like, where did this start come from? You couldn't have been a kid like, I'm gonna like look up at the stars at night or whatever, and everyone's looking at the stars, like they're so beautiful and bright, and you're like, I want to know what frequency that thing's giving off.
I've been interested in science since I can remember, but I've also been a big fan of science fiction. So I grew up with the Star Wars movies, Star Trek, Stargate SG-1, and all that kind of movies, even with the Marvel superheroes. And since I've been grew up, I've thought, oh, I like technology, I like science. I'm going to try and see if I can find a career with technology and science. And everything led to each other, where I ended up being now in radio astronomy.
You're probably
So,
looking at Star Wars completely different though. You're like, oh my God, they're shooting lasers in space. This is gonna mess up so much information.
yeah. That is, and if you look at Star Wars, yeah, with everything, the spaceships flying around shooting lasers, and you hear the sound of the lasers and crash. Space is a vacuum. You won't have sound in space.
Oh shit. Look, my buddy does a Star Wars podcast, so you
Uh,
bet your ass I'm throwing it that his way.
and one thing you can also tell him, if you see those X-wing fighters or TIE fighters in Star Wars movies, they fly around and they quickly bang to the left and right. You're not able to do that in space because you need an atmosphere with friction. You can actually bang towards and do these fast maneuvers. In space, you have no atmosphere, you have no friction. So a spaceship won't be able to move like that in space.
Now, just with your basic kind of like, how did you figure out that you wanted to go into radio astronomy though? Like the whole factor is like, even hearing that when I first kind of came across your profile on Instagram, I was like, radio astronomy, like what exactly is that? Like, are we, I know we've blasted things out into space before. Like, is anybody out there, we're playing Bon Jovi, living on a prayer, projecting it out to other planets and stuff. But how did you find out that this was exactly what you wanted to study out of the immense amount of information and first of all jobs in general that just go into research about space?
So actually quite interesting. When I was doing my undergraduate degree at the university, I saw one of the research group has flyers out and all saying they want people to do projects in radio astronomy. And I've looked at it and I thought, well, that actually sounds very interesting. I know I've heard about radio astronomy before, but I don't really know what's happening. Let me go speak to the professor and see what projects he has and what's happening. And I got a project. I did a project, and I actually enjoyed it so much that I got employed by the observatory. Yeah. Then from the observatory, I left my full-time position to do now a master's in radio astronomy that I'm finishing in the next couple of months, and then afterwards starting a PhD in radio astronomy.
Now, with just space in general, I kind of want to focus on Earth a little bit. The whole factor is with these 5G networks and all these types of things, you're hearing a lot of stuff come out about the fact that now people are getting sick from it. I've talked to someone that actually works with building the antennas as well. Is there any type of evidence with this that's causing people to get their mutation or maybe some type of brain injury or something? The whole fact maybe developing Alzheimer's earlier. I mean, when I was a kid, I used to play near power lines, and I knew when one was giving off a really low frequency that my ears could pick up. There was like a bzzz. You're like, holy shit, somebody's gonna die if they hit this. You know what I mean? Does any of that, is any of this true? Is there any worry just in your program in general?
My program, I don't think there's any worry because everything depends on the power you are putting out in this radiation. Let's take, for example, a microwave oven operates at 2.4 gigahertz in frequency. And that is used to...
Don't tell me this. You're scaring me, man. You don't know how many times I heated up a hot pocket on that fucking microwave.
So what a microwave does is, with the frequency it's emanating, it's actually causing the molecules to vibrate against each other, and that causes heat, and that causes the substance to warm up. But if you look at your Bluetooth in your cell phone, that's also operating at 2.4 gigahertz. But the intensity and power it's operating at is much, much, much lower as that from a microwave. So both operating at...
That's just safer, just so we don't get any type of brain injury or something from
Yes.
it. I feel like back in the day when even though our cell phones are technically huge now, I mean, back in the day when they were like you had two hands to hold that thing up to your head.
Yes.
People were like, don't put that up to your head. You're going to get brain cancer or something.
Yes, sir. So I don't know much about the research being done about what damage it causes to us as humans. I believe, well, what I've seen is we are still safe as long as the intensity is low enough.
Yeah, I feel like with just the overall information that we're kind of pulling out of space and all the information and first of all signals that are giving off on Earth, it would be a major concern. People would start, this is probably where you guys see a lot of friction, first of all, just in general with your program. I mean, how many people are protesting or kind of blocking your research a little bit just because of the whole factor is we're developing devices at a very, very, very fast rate. And it's hard to think that a lot of it is not impeding onto just our survival in general. I mean, if it's able to distract somebody from texting, why isn't it able, for example, I took an X-ray the other day. They told me to make sure, I had to drink a certain liquid so they could help see inside my bones a little bit better or whatever they were trying to be able to pull out. Now, I don't understand a whole lot about X-rays, but immediately when they turned that thing on, I felt the radiation from it. I know that sounds ridiculous, but it felt weird. It was more like I could feel it where I had to pee a little bit. So I was like, I could feel the liquid, whoa, I immediately started kind of getting that indigestion, that gas. I was like, that's weird. It happened exactly after a couple seconds after you turned it on.
Yeah. And that's actually what happens, because usually the substance they inject you with is called I can't remember the English word for it.
Some type of solution.
Let me quickly.
Let's just call it safety juice.
Let me. I'll come. Iodine.
Okay.
Iodine. So, and that's a radioactive element. So it's form part of the periodic table of elements, and that's radioactive, but it doesn't stay radioactive for long. So the radioactive decay usually stops in a couple of hours. So it's on a density that you can pick it up, but it won't actually cause damage to you because it's in low enough amounts, and the intensity is low enough. So you get injection with it, and that runs through your bones, your arteries. So when you do a CAT scan or an X-ray, the iodine actually reflects the X-rays or the CAT scan back. And you can also pick it up through your equipment. So that gives a more 3D image of what's happening inside your body. And you will feel it. It will cause a warm, fuzzy feeling inside you.
Okay, so that nurse was lying to me when she said I couldn't feel it. I was just or
Yeah.
I was just imagining it. I knew I felt something.
Yeah.
I was like, I
It would,
immediately get a little bit tingly on the inside. Is that anything? And she's like, no, you're just thinking about something else. I'm like, what? No, I'm pretty sure
no,
that
you'll
I just got gassy from that X-ray for sure.
yeah, you'll feel it.
So, just with your understanding with sci-fi in general, like, is there anything that kind of makes you look at sci-fi a little bit differently now? Like, you're looking at Star Wars, like with this whole vast amount of information that a lot of people are not thinking about when they're watching Star Wars.
I totally see sci-fi movies differently, especially when actually quite interesting. If you look at all these sci-fi movies, if there's aliens invading Earth or some other hostile aliens, all the aliens are basically look like humans, have 2 arms, 2 legs, head, humanoid. But who says aliens will look like that? Alien life
Exactly.
could be a floating blob. It could be some sort of snail. Who says life out of space has to look like life as we know it?
See, now my thought on this is just because when we've ever in our history been able to experiment or do some type of weird government program, whether it's like
Mhm.
testing on something, it always is in a different area because we like things to look familiar, but we can only experiment on things that really don't resemble who we are or what we
Mhm.
look like.
Yeah.
So when it comes to the idea of space, it was just an easier option to make people look, or aliens have this idea or representation of what humans are because it makes it
Yes.
familiar to us. It's basically influencing us and making so if we ever came in contact with one of them, not only will we not be able to understand if that's what they really look like, but the idea was it would be familiar into our minds so we're not all freaking out.
Yes. That's true. And one other cool technology I've been looking into quite recently is Google has become quite good at it, but also these translating apps. You say something and it gets translated into a different language. If you think about Star Trek, they have their universal translators where they can speak to different species and everything is in English and everyone can stand each other. And that's a reality that's actually starting to happen with the apps we can download. Siri can do it, Alexa can do it,
Yeah,
Google.
it's not going to be that long until we're able to get a chip into the back of our head that'll have that automatically downloaded in there. So whenever you hear something, they had at one point it was Google Glass. It was supposed to help like a translator in your ear. So
Yes.
whenever somebody would say something, the frequency would get transmitted to the Google Glass, and then you'd be able to immediately get it translated into
Mhm.
English.
And that helps. And I see there's actually a few prototypes now being developed. Is usually it doesn't matter which country you're from, you always need some form of identification, some form of identification. You need a driver's license, and everything's always a card or a little booklet or something you need to keep in your wallet or have one with you. So, and the new idea is that you have little implants, it's like the size of a small little capsule. You implant it into your wrist, and it's like an RFID tag. So you have your little scanner. You would take your wrist, you scan it against it, and on the screen pops up all your information, your medical aid
No,
information, your driver's license, your
I'm done.
ID.
I'm done. Nope. My buddy has his whole house Alexa'd up,
Mhm.
and it controls the toilet. I can't handle that. When it comes, it
Mm.
turns into the. I don't know if you ever seen the Justin Timberlake movie where everyone has a barcode on their wrist
Yes.
and they're paying for everything. I'm like, no, stop.
Yeah.
Let's get up to turn the light on. Let's not
Yeah.
clap. Let's not snap. Let's not talk to Alexa. Let's just
Mhm.
do this.
And that's actually it. interesting things happening. And some of the other interesting things I'm also watching that's science fiction that's actually becoming quite a reality now is, take, for example, the Tesla cars.
Yeah.
If you look at the sci-fi movies from the 70s, 80s, you all have these electric cars driving around. And now it's actually becoming quite a reality.
We're seeing a bunch of different theories and things happen now too, like a bunch of stuff that we started seeing. Everyone thought like, oh, by 2012 it's going to be, or by 2016, 2020 we're going to have these things like the Jetsons flying around. And it's like now only in like the past couple of years we're starting to see stuff that is really kind of expanding out. Does this kind of have any hope for the future with like just our technology advances in general? Like in your mind, do you think that we're going to be able to come across maybe a flying car in the next couple of years or maybe 20 years?
I would say probably not in the next 10 or 20 years, but in the future, we will eventually is going to get there. Technology is developing at a tremendous rate. So usually, I don't know if you're familiar with Moore's law, but Moore's law states that every 18 months, the power of the double and the physical size will shrink. I personally believe Moore's law has to be revised from 18 months now to down to 9 months. But that's going to happen in the future.
What would you say your biggest fears for just this program or research in general is, at least in your mind, compared to what your colleagues might be worried about? It seems like the program, when it comes to radio astronomy, has a lot of information for us to offer, but a lot of people aren't open to it because of the whole fact is it's not visible to us. We're more worried about like, why are we going into space when the whole idea is Earth is suffering? I'm not able to get my $5 Frappuccino. I'm not able to do this type of stuff. What is the biggest problem as a researcher do you face?
The biggest problem we are facing as a researcher is political influence. Because usually when we need funding to do these research, it's usually funded out of the Treasury Department from government. And usually from the Treasury Department, Treasury wants something in return for the research. So if you develop a certain technology to observe something in space, it helps us in the research, but the government wants something in return back. They want to know that they're not wasting taxpayers' monies. And sometimes politicians can become quite ridiculous in what's happening. For example, it's actually quite ridiculous. If you speak to scientists and engineers, they have no problem sharing knowledge with each other, no problem sharing information, designs. That's not a problem. This will help you use it. But the problem is coming to politicians where they say, oh, why do you want to share this information with that country? It needs to go through these attorneys first to make sure it's not getting stolen or used. Well, we can just say, yes, the information, use it.
And just with political in general, it seems like we have more, I guess, at the front type problems instead of worrying about these types of scenarios, such as getting funding to understand more research. It seems like anytime, same reason why you're in Africa right now. The whole
Yes.
concept is there's a lot less radio wavelengths given off in Africa than there is here. We have a big problem of it probably has to do with overpopulation as well.
That as well, everywhere where there's a radio telescope and even optical telescope, you try to keep it away from big population densities. For optical telescopes, it's just to the fact of light pollution. There's a lot of people, there's going to be a lot of houses, a lot of buildings, big cities, and that causes lights. And that light will blur out images on optical telescopes. The same thing happens with radio telescopes. All of these people have cell phones. They want the internet, so everyone will have a Wi-Fi connection, and that causes interference on these telescopes. So we try to build these telescopes on remote locations just to eliminate all these kinds of interference and problems.
Now, through all your research and kind of your understanding of being able to, first of all, uncover what all the information that's out there that a lot of people are not kind of known to, what's one thing that still sticks into your mind that either we have left to discover or it's more of a factor of like you're worried about it, like you as a person?
Ooh.
Because I feel like just knowing a little bit more about the sun, and the whole factor is you're telling me that it's going to expand out, even if it's a couple billion years from now, I'm still fucking thinking about it like, oh, well, if that's able to happen, then what else isn't able to happen?
So one other thing, I don't know if the listeners is aware of it, but our closest galaxy to ours is the Andromeda Galaxy, and we are in the Milky Way galaxy. So in a couple of these two galaxies are moving towards each other. So in a couple of billion years, these two galaxies will also collide. That means there's a possibility that certain stars will collide with other stars. Planets will collide with other planets, and there's just going to be chaos if these two collide. So that's going to happen in a couple of billion years. But saying that as well, this will also cause something beautiful to happen. That will, because no one has actually seen two galaxies collide. We can see the remnants of it, but that's actually something we can see going on. And something interesting that's popped up now in the scientific community the last 2 weeks is the star Betelgeuse. It's a super red giant that's bigger than our own sun. And that's also one of the brightest stars in the night sky, especially in the southern hemisphere. But in the last 2 weeks, the Betelgeuse, its light intensity started to dim. And everything suggesting, pointing towards that Betelgeuse is about to go supernova. We don't know when. It could be in the next couple of years, the next couple of 100 years, but it will go supernova at some point. And in our own history, I've only seen one other star before go supernova. So this is also going to be something quite interesting to monitor and see what's happening.
Not only did you say Beetlejuice 3 times, you know you're not supposed to say Beetlejuice 3 times, but the whole concept of first of all, I have a couple questions on this.
Yes.
First one, where do they come up with the names for the stars and the galaxies? Like Milky Way galaxy, how did you decide to name it that? Were you looking at a box of Milky Ways? I'm curious. Did these ideas ever pop into your head? I just want to make sure I'm not like an idiot here. I feel like you're doing a lot of research, you're understanding more about stars and galaxies. You're kind of wondering why we're naming them such weird names or different names.
That's actually quite interesting. So usually how it works is if you discover a certain object, the person that made the discovery can name it whatever he or she wants. But usually in astronomy, there's usually a visual representation describing the name or a traditional sense of naming things. So if you look at our Milky Way galaxy, if you look up in the night sky, you'll see where there are more dense or star populations packed together. The night sky will appear milky, like there's clouds in the sky. Even there's no clouds, it seems like clouds, and that looks like milk, and that's what's called the Milky Way. And the same with the different stars like Betelgeuse. That's just sometimes people named it. If you look at our own solar system, if you look at the different moons around Jupiter and Saturn. So take, for example, the moons around Jupiter. They are named after Greek gods. So the spacecraft Juno that went to Jupiter and Saturn a couple of years ago, it was named Juno because Juno is one of Jupiter, the Greek god Jupiter's lovers. So Juno actually went to check on Jupiter. That's actually quite an
Yeah,
entertaining way.
that's Roman mythology.
Yeah, of Roman mythology, yes.
This is my
And
that's my guilty pleasures. I know a lot about Greek gods and Roman
uh,
gods.
so each of the moons, the name of after one of these gods. And if you look at Saturn, that's the only planet in our solar system that's not named after Greek or Roman gods, but it's actually named after characters in Shakespeare's plays.
Oh, well, that's crazy because
Yeah.
I know Uranus is actually a name of a Roman Titan.
Yes.
Yeah.
And the same, the two moons of Mars, Phoebos and Deimos.
Yes. And then Mercury is also in Greek mythology, or actually Roman mythology.
Yes. So that's where everything comes along. And if you look at different skies, in a sky, different stars, And a couple of thousand years ago, was looking at the 10th to 15th century. The Middle East were actually leading the front in astronomy research. So a lot of stars actually has Arabic names. That's
Okay.
just an interesting fact.
So not even only the fact is that they get their names not from just the person's idea or whatever they choose to name it, but
Yeah.
the idea of the time period that it was well and kind of that we figured this
Yes,
information out.
yes.
So this brings in a good question. What if you could find a star, if you could name a planet, what are you going to name it?
Ooh.
You've had to had one idea pop into your head.
Yeah, I have. Usually, when I try, if I'm thinking about naming planets, I usually go back to sci-fi and imagine like something like Vulcan or Romulus.
Something, it's got to be extreme and it's got to be badass.
Yes.
But it's also has to do with upon your discovery as well of being able to kind of look at the features and the things that it might represent. Like when you name a dog, you see a dog, you're like, that's like you would know it when it hits you, you know, that whole concept. I feel like if I'm gonna name, you know, we get things like RN 5426 Magnum as like a fucking planet or something. I'm like, how do
Yeah.
you get that name? How does that strike you as that? Like when a person names a kid, they're like, this is a Chuck. No, like, but they give a specific number. Now there's so many out there that we really didn't know. Back in the day, we only thought there was a few planets. We didn't know that there was other galaxies, and then eventually figured out there's galaxies to the point now we're just numbering them off. I feel like if I was going to name one, I would name it something badass like Beowulf or Planet 69.
Yeah, so that actually happens. So everything we look at at space has a number as a name and an actual name. So the number is usually just to classify it. So if it's an asteroid, it will start with a certain number. If it's a planet, it will start with a certain number. If it's a star, it will start with a certain number. Then if it's above a certain size, another number will be added. And if it's a certain color, a number will be added. So it just helps to catalog what's out in space. And then you can name it like Beowulf or something badass that you want as well.
I'm still waiting on your answer for that planet name. If we had to think of a giant name for a sun, what would you call it?
Ooh, that's a very, very good question.
Ah,
You're putting me on the spot here.
yeah, improv it. Go. What would you first thing that comes to your mind? Let's picture a giant orange sun. What would you call it?
Probably something like Demos.
I like that. I like the
Yeah.
Roman kind of little aesthetic to it too. It makes it sound like it's evil, but we don't know yet.
Yes.
Now, if you had to give any advice out there to someone that maybe wants to dive into the realm of radio astronomy, what would you say to them?
I would say don't be afraid of it. If you are enjoying science and enjoying technology, just start up read up about it. And if you really want to find out more about it, just start contacting people that's in the field. If any of your listeners has more questions for me or is interested, you're more than welcome to point them towards me, and I can point them in the correct, in the right way. And there's also a lot of help on the web available. If you just start Googling radio astronomy, most universities and colleges will have a program for radio astronomy. But that's something you can read up about and start forming your opinions about.
Well, if people are going to go and find you, I want to give you here a minute at the end kind of to promote your page and also your content as well. So people can be able to contact you with any questions or maybe even look up their own research where you can help guide them to
Oh,
just
yes.
understanding radio astronomy in general.
Right. Yeah, they're more than welcome. Okay, so for all the listeners, if you want to find me, you can find me on Facebook, Instagram, and Twitter. So my name is Heystek Grobler. You spell it Heystek Grobler. So if you want to find me on Instagram or Twitter, it's just everything lower caps, one word, Heystek Grobler. At Heystek Grobler, you can find me on Instagram and Twitter. And if you want to send me an email, same thing, heystekgrobler@gmail.com.
Well, thank you so much for listening to this episode of Out of the Blank podcast and stay tuned for our next episode.